video, we'll look at some more complicated examples of using the elimination method to solve simultaneous linear equations. So if you haven't seen the previous video, I'll pop the link up in the right-hand corner so you can watch those first. Once again, we start by numbering our equations, number 1 and number 2. And we need to decide which variable is being eliminated. Now in this case, our x variables both have different coefficients, and our y variables both have different coefficients in both of the equations. So if we were to add or subtract our equations together at the moment, we wouldn't eliminate any variables. So that's not going to be the right thing to do. We need to somehow change one of our equations so that they do have the same variables, coefficients for the variable terms. If we look at the second equation, the x coefficient is a 2. And in the first equation, it's a 1. What could we do to that term, or to that whole equation, so that the x had a 2 coefficient? Well, we could multiply it by 2. We could take the whole of equation number 1 and multiply it by 2. Now, this equation will still be true. If you double what's on both sides of equations or both sides of a set of scales, it will still be balanced. So let's take equation 1 and multiply it by 2. And that's going to be equal to, let's call it a new equation. We'll call it number 3. Because we're going to get a different equation when we multiply by 2. We start with the first term, which is x. X multiplied by 2 is 2x. Then we have minus 5y times 2 is minus 10y. Then we have equal to, on the other side, negative 17 times 2, negative 34. When we multiply our equation by 2, we have to make sure every single term in the equation is multiplied by 2. Now, this equation that we've calculated here, that we've created, has the same solution as number 1 and number 2. And so we can proceed with our elimination method because now equation 2 has 2x and equation 3 has 2x as well. They both have a 2 on that coefficient for the x variables. So let's line up our equations. Number 2 is 2x plus 3y equals 5. Instead of using equation 1, we turned it into equation number 3, which is 2x minus 10y equals negative 34. And we decide whether we add or subtract. The signs are the same, they're both positive, so we need to take away here. And we have 2x take 2x is 0. Fantastic, we've got that elimination we were looking for. 3y take negative 10y. When we take away a negative, that's the same as adding, so that's plus 13y equals 5 minus negative 34. 5 minus negative 34 is the same as adding, and so that gives us 39. Our equation becomes 13y equals 39, and that's much simpler for us to solve. We divide both sides by 13, and y equals 3. So we found one of our variables, and to find the other, we substitute into one of the equations. It can be any of the equations, 1, 2, or 3. They will all have the same solution. So let's substitute y equals 3 into equation number 1. That's the one I'd like to do. And so we have x minus 5 times 3 equals negative 17. X minus 5 threes is 15 equals negative 17. We add 15 to both sides, and we're left with x equals negative. And so we can write our solution. Therefore, solution is x variable first minus 2, and then y, which is 3. Let's look at the second example. Now, in these two equations, once again, the x variables have different coefficients and the y variables have different coefficients. So we know we're going to need to change these equations. In our first example, we could easily multiply the first equation by 2, and that gave us the same coefficients for the x variables. But in our second example, there's nothing that we can easily multiply just one of the equations by. So in this case, we're going to need to multiply both equations so that we get the same coefficient for one of our variables. Let's number our equations 1 and 2. We need to decide which variable will be eliminated. We can choose in this case because neither of them have the same coefficients. Let's do y. Let's eliminate y because 5 and 4 are smaller values than 6 and 5. It'll just keep our numbers a bit smaller. So looking at equation number 1, our y variable has a 5 coefficient. And in equation number 2, the y variable has a 4 coefficient. And we need them to be the same. So let's create some new equations. Equation number 1, what do we need to multiply that by? Well, the lowest common multiple of 5 and 4 is 20. So we need to multiply 5y by something to get it to be 20. The whole of equation 1 needs to multiply it, and that's 4. That's going to give us equation 3, our new equation, which will be 6x times 4 is 24x, plus 5y times 4 is 20y, equals 3 times 4 is 12. Now we also need to change that second equation. So let's take equation number 2. What do we need to multiply equation number 2 by? Well, our lowest common multiple is 20, and we need 4y to get to 20y. So let's multiply that by 5. And we'll call this one equation number 4. We have got 5x multiplied by 5 is 25x. 4y multiplied by 5 is 20y. And 2 multiplied by 5 is 10. And now both of our y variables have 20 as their coefficient, so that's going to be able to eliminate. So we stack up our equations. Equation number 3 on the top, 24x plus 20y minus 12 equals 12. And equation number 4 is 25x plus 20y equals 10. And we just need to decide whether we'll add or subtract. They have the same signs, so we need to subtract. 24x minus 25x is negative x. 20y minus 20y is 0. 12 minus 10 is 2. So we have negative x equals 2. If we divide both sides by negative 1, we're left with x equals negative 2. We found our x variable, we just need to find y as well. So we're going to sub x equals minus 2 into one of the equations. It could be 1, 2, 3, or 4. It'll give us the same solution for all of the equations. So let's pick number 1, where we have 6 times minus 2 plus 5y equals 3. So negative 12 plus 5y equals 3. We add 12 both sides. We've got 5y equals 15. Divide both sides by 5. And we're left with y equals 3. So we can write our solution, therefore, solution, not solution. Solution is x was minus 2 and y was 3.